March 12, 1943, Piedmont Army Research Center, Germany. Professor Erich Schumann adjusted his thick wire-rimmed glasses as he leaned over the glowing vacuum tube array. The hum of generators vibrated through the concrete bunker, mixing with the sharp crackle of high-voltage arcs. His fingertips brushed the cold metal casing of the prototype Luftstrahlkanon, air-jet cannon, a weapon he claimed could slice through enemy bombers at 50,000 feet. Outside, a light snow fell on the Baltic coast, covering the facility's smokestacks and camouflage test ranges. Inside, Schumann's team of 32 engineers and physicists waited, their faces taut with a mix of anticipation and dread. They knew failure here could mean a one-way trip to the Eastern Front. Success might turn the tide of a war sliding steadily against the Third Reich. The idea of a death ray was not new to the Third Reich. As early as 1935, Heinrich Himmler's SS had begun funding fringe science projects, convinced that exotic weapons could deliver Hitler's 1,000-year Reich. The Luftwaffe, struggling to counter the growing threat of Allied bombers, had latched on to Schumann's proposal with desperate enthusiasm. His concept was deceptively simple. Focus intense microwave radiation into a narrow beam, heating the metal fuselages of enemy aircraft to the point of structural failure or igniting their fuel tanks. It was a weapon of promise, silent, invisible, and potentially unstoppable. But translating theory into reality would push German engineering to its breaking point. Schumann, a respected physicist at the University of Berlin before the war, had built his career studying electromagnetic radiation. His early work on radar had caught the eye of Luftwaffe Chief Hermann Göring, who approved a 2.5 million Reichsmark budget for the project in 1940. The Piedmont facility, best known for its V-2 rocket program, was chosen for its remote location and access to cutting-edge manufacturing. By 1942, Schumann's team had outgrown their initial lab and moved into a purpose-built bunker with 3-foot-thick concrete walls, designed to contain accidental explosions and shield the project from Allied reconnaissance. The core challenge lay in generating and focusing enough energy. Schumann's first prototype relied on a bank of modified radar transmitters, each capable of producing 100 kilowatts of power. When linked together, they created a beam with a wavelength of 10 centimeters, enough to heat a sheet of aluminum to 200 degrees Celsius in 30 seconds. But range was a problem. Early tests against the stationary Junkers Ju-88 fuselage succeeded at 500 yards, but the beam dissipated rapidly beyond that distance. The Luftwaffe demanded a weapon that could engage targets at 5 miles, well beyond the reach of conventional anti-aircraft guns. To boost power, the team turned to a new type of magnetron developed by Siemens. The device, roughly the size of a football, could produce 500 kilowatts of continuous microwave energy. By stacking 6 of these magnetrons in a hexagonal array, Schumann believed he could create a beam powerful enough to disable AB-17 Flying Fortress at 3 miles. The focusing system, a parabolic reflector coated in polished copper, was another engineering feat that had to be precision machined to within 0.1 millimeters to keep the beam tight over long distances. Siemens' factory in Nuremberg worked around the clock to produce the components, using slave labor from nearby concentration camps to meet the brutal deadlines. By January 1943, the prototype was ready for its first live test. A captured British Spitfire was anchored to a concrete pad 2 miles from the bunker. Schumann's team activated the generators, and the bunker's control room filled with a high-pitched whine of power being routed through the system. On a bank of oscilloscopes, green traces showed the beam locking onto the target. For 60 seconds, the Spitfire was bathed in invisible radiation. When the beam was shut off, a team of engineers approached the aircraft. The aluminum skin around the fuel tanks was discolored and warped, and the rubber seals in the engine compartment had melted. A subsequent test with a full fuel tank resulted in a small explosion, confirming the weapon's potential to ignite ordnance. Goring visited Peenemund soon after, arriving in a convoy of staff cars with a retinue of senior officers. He watched the demonstration where the death ray disabled a dummy bomber at 1.5 miles and declared it the future of German air defense. He authorized an additional 5 million Reichsmark to scale up production, ordering 10 operational units to be deployed along the Western Front by the end of 1944. But the celebration was short-lived. Allied bombers had begun targeting German industrial facilities, and Siemens' magnetron factory was hit in a raid in February 1943, delaying production by 3 months. Worse, the weapon had a fatal flaw. It required enormous amounts of electricity. Each unit needed a dedicated 2-megawatt generator, which weighed 15 tons, and required a team of 12 men to operate. Transporting these generators to the front lines was logistically impossible, especially as Allied forces gained control of the skies and roads. Schumann proposed building fixed installations along the coast and major cities, but this limited the weapon's usefulness. The Luftwaffe wanted a mobile system that could be moved to hot spots, not static defenses that could be destroyed by precision bombing. Undeterred, Schumann's team worked on a smaller version. They replaced the 6-magnetron array with 2, reducing power to 1.2 megawatts, but cutting the generator weight to 8 tons. This mobile prototype was mounted on a modified tank chassis, with a parabolic reflector housed in a retractable turret. Tests in June 1943 showed it could disable a B-17 at 1 mile, but the beam was easily disrupted by rain or fog. The microwave radiation was absorbed by water droplets, scattering the energy before it reached the target. In the unpredictable European climate, this made the weapon unreliable at best. The project also faced internal resistance. The V-2 rocket team, led by Wernher von Braun, resented the resources being diverted to Schumann's death ray. Von Braun argued that rockets were a more practical solution to the bomber threat, and he lobbied Göring to cancel the project. Meanwhile, the SS grew increasingly suspicious of Schumann's team, which included several Jewish scientists who had been granted temporary exemptions from deportation. In August 1943, the Gestapo arrested 3 engineers on charges of sabotage, accusing them of deliberately slowing progress. They were executed 2 weeks later, and Schumann was forced to purge his team of anyone with questionable loyalty. By late 1943, the tide of the war had turned. Allied forces had invaded Italy, and the bombing campaign against Germany intensified. Peenemund itself was targeted in a massive raid in August 1943, with British bombers destroying much of the V-2 production facility. Schumann's bunker survived, but the attack highlighted the vulnerability of fixed research sites. The team was forced to relocate to a former salt mine in the Harz Mountains, where they continued work in cramped, damp conditions. The move delayed development by 6 months, and many of the precision components were damaged in transit. Despite these setbacks, Schumann's team made a breakthrough in early 1944. They developed a new type of waveguide, a hollow metal tube that channeled the microwave beam more efficiently, reducing energy loss by 40%. This extended the weapon's effective range to 2 miles, and improved focus and allowed it to target specific parts of an aircraft, such as a cockpit or engine. A test in March 1944 against a captured B-17 resulted in the bomber's left engine catching fire within 45 seconds of beam contact. The Luftwaffe was impressed and ordered the first operational unit to be deployed to the Western Front in June 1944, just in time for the Allied invasion of Normandy. The deployment was a disaster. The mobile unit, transported by rail to a position near Cannes, was discovered by Allied reconnaissance aircraft before it could be fully operational. On June 12, 1944, a squadron of American P-47 Thunderbolts bombed and strafed the site, destroying the generator and damaging the reflector beyond repair. The crew of 15 men was killed in the attack. Schumann, who had traveled to the front to oversee the deployment, narrowly escaped capture by fleeing into the nearby forest. If you found this interesting, get a thumbs up to show your support. Drop a wonderful in the comments to let me know you're still with me. Stick around till the end, because I'll reveal 3 mind-blowing facts you won't want to miss. Haven't followed yet? Hit that follow button so you won't miss our next deep dive. Trust me, the best is yet to come. Back in the Harz Mountains, morale plummeted. Resources were growing scarce, and many of the remaining engineers were conscripted into the army. Schumann begged Göring for more funding, but the Luftwaffe was now prioritizing fighter production and anti-aircraft guns. In September 1944, the project was officially scaled back, with only a skeleton crew retained to continue research. Schumann refused to give up, however, and began working on a smaller, handheld version of the Death Ray, designed for use against tanks and infantry. This prototype, powered by a portable generator, could produce a 100-kilowatt beam that could ignite clothing or disable tank electronics at 100 yards. But it was never tested in combat, as Allied forces were already closing in on Germany. In April 1945, as American troops advanced into the Harz Mountains, Schumann ordered his team to destroy all documentation and prototypes. The Death Ray's blueprints were burned, and the magnetrons and reflectors were smashed with sledgehammers. Schumann fled to Bavaria, where he was captured by American forces in May 1945. He was interrogated at length about the Death Ray project, but he downplayed its success, claiming it had never progressed beyond the experimental stage. Fearing prosecution for his role in using slave labor, he lied about the weapon's capabilities, telling his captors it was a futile attempt to harness improving technology. The Allies were skeptical. American and British scientists had been monitoring German exotic weapons research since 1942, and they had intercepted several reports about the Peenemünde Death Ray. A team of American physicists was dispatched to the Harz Mountain site, where they found fragments of the prototype and interviewed surviving team members. Their report, declassified in 1978, concluded that Schumann's weapon had been technically feasible and that it could have posed a significant threat if deployed earlier. Schumann was never charged with war crimes. Instead, he was recruited into the American Operation Paperclip program, which brought German scientists to the United States to work on Cold War weapons projects. He was assigned to the RCA laboratories in New Jersey, where he worked on microwave communications and radar systems. He never returned to Death Ray research, but his work laid the groundwork for modern microwave technology including the magnetrons used in household microwave ovens. He died in 1962, his role in the Nazi death ray project largely forgotten. The legacy of Schumann's death ray is a complex one. It was a weapon of enormous potential, born from the desperation of a regime fighting a losing war. Its development pushed the boundaries of electromagnetic technology, but it was ultimately undone by logistical constraints, Allied bombing, and the moral rot of the Nazi regime. The use of slave labor to build its components is a stark reminder of the human cost of such weapons programs. For military historians, the death ray stands as a cautionary tale about the dangers of prioritizing exotic weapons over practical ones. The Third Reich poured millions of Reichsmarks into projects like the death ray, the V-2 rocket, and the Me-262 jet fighter, while neglecting basic needs like sufficient anti-aircraft guns and fighter pilots. These wonder weapons failed to turn the tide of the war, and their development diverted resources for more effective defenses. Today, the ruins of the Peenemünde bunker and the Harz Mountain salt mine are quiet reminders of the Third Reich's failed quest for technological supremacy. The fragments of the death ray prototype, stored in archives in Washington and Berlin, serve as a testament to the ingenuity of the engineers who built it and the folly of the regime that funded it. In the end, the Nazi death ray was a victim of its own ambition. It promised a quick, decisive victory, but it could not overcome the fundamental weaknesses of the German war machine: limited resources, poor logistics, and a leadership willing to sacrifice practicality for propaganda value. It was a weapon ahead of its time, built by a regime behind the curve of history. And while it never fulfilled its deadly potential, it remains a haunting example of how science, when twisted by ideology, can be turned into a tool of destruction. The story of the Nazi death ray also raises important questions about the ethics of scientific research. Schumann was a brilliant physicist, but he chose to use his talents to serve a murderous regime. His work on the death ray was driven by a desire to win the war, not by any moral consideration of the weapon's impact. It is a reminder that scientists bear responsibility to consider the consequences of their work, even in times of conflict. As we look back on World War II, the death ray is often overshadowed by more famous weapons like the atomic bomb. But it deserves to be remembered, not just for its technical innovation, but for what it reveals about the Third Reich's final days. It was a last-ditch attempt to grasp at victory, a Hail Mary pass from a regime that knew it was losing. And like so many other Nazi projects, it failed, not because of lack of ingenuity, but because it was rooted in a system of oppression and destruction. In the end, the most powerful weapon of World War II was not the atomic bomb, the V-2 rocket, or the death ray. It was a collective will of the Allied forces, united in their determination to defeat fascism. The Nazi death ray was a weapon of fear. The Allies fought with hope, and hope, as history has shown, is a far more powerful force than any ray of death.